Good afternoon. We start again. We resume our lecture. What we've done so far is we tried to generate some motivation for why we should be looking for quality. What is the benefit to a company? Why does the organization really have any kind of thrust to go toward better quality? That's like something, there's a marketing edge there, there's a competitive advantage there, and you basically impact your product line, you impact your processes, and so on and so forth. And the ultimate impact is on your bottom line. That's where you really begin to see the benefits. If you look at a system, and the kind of system that I have on the screen here, any system that you're operating, it's impacted by many different materials. And in the traditional view of things, you've got materials, measurements, methods, machines, people, and so on. They all impact the output. And if you just look at the output, you remember the diagram I showed you earlier in the first session. The diagram has an output that has got wide variation. This wide variation is there because many of these factors which are on the input side, they are not in good control, or they have not been set at their optimum points. Now, this is very important. So, the movement towards Six Sigma is to make sure that this variance actually is well within your controllable, within your acceptable conditions. It's very, very important. And it's also important for us then to understand which of these parameters should be manipulated and how. And that is done by this technique called DOE. So, we'll take a look at that gradually as we go into this. So, we start with what I have on the slide here. I have basically your diagram, and that is showing us the system. If you look at a real factory really does pose a lot of challenge in controlling quality, because there are so many variables there, so many factors there, so many conditions there, and they are not always in your control. And things may change without any notice. Things may change, conditions may change. Rain may be there. Other disturbances may be there. Voltage may fluctuate. Raw material arrival may be different. You might have a trainee on the job, and so on and so forth. All those things that would impact quality in some way. The machine may start malfunctioning, as an example. Tools may wear out, tools may break, and so on. All these things, they will eventually have an impact on your quality. The result is this, what you see on the right hand side. There is production that is in the off-spec area, the red area to the right and red area to the left. It's very difficult to sell anything that turns out to be on the left or on the right of what we call the spec limits. Spec limit is the range that the customer will accept. Anything that goes outside the spec limits, I cannot sell that product. I'll have to basically scrap it or perhaps rework, which is going to raise my overall production cost. So, that being the picture, it's not really such an easy job to try to control it, but there is no choice. If I am going to be in business, I'll have to do it. What has been the traditional focus? If you look at the traditional focus of quality management, it's been really to try to look at short-term profits. And many times people have looked at the stock price instead of trying to do something about their process, the manufacturing process or the service process. They have looked at the market. They're trying to get signals from, Dalal Street or some other place to try to get a signal, or look at the Dow Jones and so on. From that, they are trying to get a signal how they should be operating their company. Is that the way they should really be operating their company? After all, the low price of the market, low price for their stock in the market, that's a reflection of what customers, or shareholders, they expect to come out of the company in future. That is what is reflected there. If I do not control the process that's going to deliver good products and good services, obviously prices are going to crash. So, it's almost like the tail trying to wag the dog. That's what is going on. So, that is the traditional view. No clear strategic position. In fact, there is very poor competitive positioning. With respect to your customers, there is very poor competitive positioning of the company. That's the traditional way of doing the company. They try to clamp down cost regardless of what is the nature of those costs. If these are preventive costs, should I also shut those down? Should I also try to make sure I do not do any training and so on and so forth? I do not use good quality materials, I do not use good quality tools and so on, because that's going to save me some money. Should I do that? Should I go that way? Obviously, these are some of the problems with traditional way of managing it. And then, of course, in some businesses, the situation is that the attitude is, because of the monopolistic situation, take it or leave it. That is the attitude toward customers. We don't really care to hear what they are saying. Pretty soon they'll start voting with their feet. They're going to walk away. They're going to go somewhere else. Also try to buy things at the lowest price. We buy cheapest materials, cheapest labor and so on. And many times what happens, the real knowledge to fix the process is really with the people who are working on the job. They are the guys who are operating the machines. But what happens? People sitting in air-conditioned chambers, they are the managers and so on and so forth. They are the guys who are trying to look for problems. They are trying to look for solutions. Many times they'll snoop around, they'll locate a problem, they'll try to solve it in their own way without involving people who are on the shop floor. That is also one of the things that is wrong with the traditional way of doing it. Here's an example. Here's an example that required really a different approach altogether. There was a company. This company was in the trading business. They operated a very large supermarket in Kuala Lumpur. They were like sort of the Walmart and the Big Bazaar and so on. That's the kind of scale at which they operated. And what they realized was there was a big market for chocolate bars in Kuala Lumpur. There were a lot of little kids and they all wanted to get good chocolate bars. That's something that was very favorite. It was a big hit in the marketplace. So what these folks, these people who were operating the supermarket, what they thought of doing was, oh, they would get some European product. They'd get some European chocolate bars and they would just bring them to Kuala Lumpur and sell them. And yes, some kids loved them and so on. The taste was good and everything else. But pretty soon the mothers started to complain about these chocolate bars. It was not so much that the mothers themselves, they were chewing on the chocolate bars. No, mothers were not eating those chocolates. What mothers were most concerned about was when they put the chocolate bar in the pocket, the bar started to melt. And the kid came up with a big blob of chocolate stain on his pocket. And this is something that happened because the European formulation became very fluid at the high temperature, high ambient temperature in Kuala Lumpur. As you probably know, Kuala Lumpur in summer days has temperatures that range between 95 and 105 Fahrenheit. That's pretty high temperature. That's almost like 40 Celsius. That's pretty high temperature. And most European chocolate formulations, they basically melt. The bars will first bend, then they'll just drop off. That is not something that obviously mothers would like. What about kids? Well, kids had gooey hands. All over the place they had chocolate. They had chocolates on their shirt, they had chocolate on their hand. So this was a product that quickly turned out to be not a very successful innovation in the marketplace in Kuala Lumpur. Somebody started thinking about it. What could I do with these bars? Should I try to package them better? Should I put like insulation around the chocolate bars? But when the kids start eating them, they'll have to take them off. They'll have bare chocolates in their hands, and again hands would be gooey and so on. So what could be done? They did something called quality engineering. They changed the recipe of the chocolate bars. So the red line here, it shows the performance, the high fluidity of the European bars. As temperature went up, the European bars became more and more plastic. Eventually they ended up melting. But a better formulation that was found by doing DOE was the robust design, that is this green one here, green bar. This bar had certain different recipe. The recipe itself was different. And it would hold on to its firmness. It would not be something that would become just melting and so on and so forth. It won't become a blob. It was something that could retain its shape. That was a robust chocolate bar. And this was the product of starting with a red bar. Starting with a red bar that went like this and converted into a green bar. So the red bar got converted into a green bar. Then of course you had a robust and a very successful product. This product sold very well because it now listened to the customers. It picked up the signals from there. It did R&D. It did the DMAIC. It did the DMAIC all the way from the beginning to the end, and the impact was directly on the bottom line. Let's take a look at what is a good point to shoot at. For example, when people talk about specifications, when people talk about customer requirements, where is it that the customer is going to be maximally happy? My shirt size is size 42. My shirt size is 42. The shirt that I'm wearing is size 40. And just look the way, when I try to put this last button, I can't even get it there. Because this is a shirt that was gifted to me by somebody who did not really know my correct size. And he just saw a nice shirt. It's a lovely shirt. And I adore using this. Whenever there's like a fancy party or something, I put on this particular shirt. So I have it always washed, pressed and ready for me whenever I have to go to a public place, provided I do not have to put on a tie. That of course is the critical thing. because the size here is, this size is 40 and my real size is 42. So what is the point, what is the shirt size that will make me the happiest? That is size 42, not a size 40. And of course, if I get a dhila dhala shirt, if I get a loose shirt which is size 44, again I will not be using that shirt because it will be hanging, and it will be something that I cannot use in a formal occasion. So what I have to do is, what the supplier has to do, or what the purchaser has to do, someone who is trying to make me happy, is to provide me a shirt that is of size 42. That will make that will really raise my satisfaction to the highest level. Who recognized this? It was this gentleman Taguchi in Japan. He is the one, he said, and if you look at the diagram here, there is a point here that is called the target. The target is the value of the quality characteristic. If you deliver your product at this level, the customer is going to be happiest. Like Professor Bagchi being happiest when the shirt size is 42. That is this point. So this point for me is 42 centimeters. What about specification limits? Is it possible that I specify my shirt size to be 42 plus minus 1 or plus minus 2? Suppose somebody loosely specifies my shirt size to be plus minus 2. So then someone who is trying to buy a shirt for me, he'll probably buy me a size 40 shirt or a size 44 shirt because they're all within spec limits. The spec limits have been given as plus minus 2. The problem is this, my dissatisfaction is going to rise. If you look at the red line, if you look at the red curve, it rises on both sides away from size 42. And that's actually a loss. What this is showing is the y-axis is the loss. Loss is minimum right at the target. And loss rises if I go away to the right hand side of the target or if I go away to the left hand side of the target. Now, what has been the traditional view of quality control? Well, you locate these spec limits. God knows how these spec limits are fixed. But somehow you locate the spec limits or you just put them on the drawing. You write down plus minus 2. So there will be a shirt drawing there, some dimension will be given there. And some fellow who is doing the drawing, from his own head he will put down plus minus 2. As if I am going to be equally happy with a size 40 shirt or a 42 shirt or a 44 shirt. That's not true. I am happiest only at size 42. 42 basically. 40 is no good for me, 44 is also no good for me. So my satisfaction is highest when the performance delivered is right on target. This was realized by Taguchi. Taguchi also said something more. Taguchi said when you are trying to do production, please try to make sure your production is also as close to the target value as possible. That is the ideal quality point, and if you deliver your products right exactly at the ideal point, the customer is going to have maximum satisfaction. The moment you go away slightly to the right, slightly to the left, as I show on this curve here, as the cursor moving to the left or the right, dissatisfaction or losses, they increase. It increases this way, loss increases this way, and also loss would increase this way. And of course, if you go too far, it's going to be off spec anyhow. So there's not much sense in trying to produce something that is going to be off spec. But even if you watch your specifications, the best thing to do is to try to produce products that are right at the target and neither to the left nor to the right. Let me tell you this little story. This is about Sony TVs. You know, Sony is a very successful TV company. And this story is given in Juran's Quality Control Handbook. If you look at Juran's handbook, you will find the story there. The Japanese, they produce TVs, like they produce cars and so on and so forth. They produced a lot of electronic things and they also produce cameras, optical products and so on. They produce TVs. And one of the kinds of TVs, the model was called Sony Trinitron. It was very popular in the US. It had very fine performance. When we were students, we all lined up to buy a Trinitron TV. So we tried to save enough money to be able to afford maybe a small size, but perhaps only a small size, but a good Sony Trinitron TV. That was our dream. Like it was to try to get an Asahi Pentax camera. It was like one of those elite things. Or perhaps a Toyota car today. That would be the target. That would be the ultimate that we would like to get to. Because these had quality reputation. Now, what about this Sony Trinitron TV? It certainly was a TV that was liked by a lot of people. What happened was, these TVs basically they took over almost 50% of the US market. And this was complained about by many others who were actually producers of TVs. And they started complaining. They started saying, well, the Japanese are doing dumping here. They produce whatever they produce, but they are basically taking away our market. And that was a proper call, because that is what was happening in the marketplace. And what did the Japanese do? They said, fine, I think what we'll do is, we'll bring the parts, but we'll let the American workers assemble the TVs. So yes, there will still be Sony TVs, Sony Trinitron TVs, but the assembly will be done right here in a town called San Diego, which is in California, at the southern tip of California. That's where Sony, they set up a factory, a Sony TV Trinitron factory there, and they started producing their TVs there. Everything went fine for a short time. Pretty soon, the moment the Japanese trainers and so on, they left the factory and they went back to Japan. The San Diego factory, it had all American workers. They started producing TVs, like routine, for example. Now, something funny happened in the marketplace. People, when these TVs, they reached the marketplace, the shelves, people started to complain about these TVs. There were suddenly Sony TVs, Trinitron TVs, they were not as popular. They were not seen to be offering the same quality, the same clarity as the older Trinitron TVs were doing. What was the problem? Well, the Sony people, they came back. They took a look at the practices. They took a look at the assembly practices in the San Diego plant. And what they found was that there was some quality characteristic. I'm going to be showing that in the lower half of the screen there. Some quality characteristic, it could be maybe the sharpness or something. Let's say it is sharpness. Now, the engineers in San Diego, they understood what the target was. So they knew this point. But they also, put up on their own pretty well, they put up a spec limit. They said as long as sharpness is the final sharpness of the TV that has just been assembled, it stays within this range, you can ship that TV. So they set up these limits, which were specification limits. It's not very clear how these limits were set, but they're set for convenience. Otherwise, forever you will be doing quality control. So that to try to make it easy for production people, what these supervisors did was, in San Diego, they set up these limits. These were specification limit, the upper spec limit and the lower spec limit. And they started their routine production to just make sure that sharpness stayed in this range. That's all. Now, the curve here inside, that is typically the distribution of TVs, the sharpness of TVs that are made in Japan. The reason was this: in Japan, they tried to fine tune the sharpness of the TV so as to make the final sharpness come as close as possible to this target value, That was the goal. That was the goal of production in Japan. But in San Diego, it turned out to be, just try to be within these specifications, you'd be okay. Now, naturally, when the San Diego TV, they hit the marketplace, there will be some TVs that will be marginal in performance over here, and some TVs that will be marginal in performance over there, and people would not be happy with them. Same sort of thing also were found with automotive parts and many other applications. When the shift went away from trying to produce on target to try to come within some specs, the same problem was seen. So this again, there was a theoretical idea. Taguchi's idea was somewhat theoretical. He was saying, please try to produce on target. But some people said, well, traditionally we've been producing within specs. What's wrong with it? The customers provided the signal. The customer said, we are the happiest when my shirt size is 42 and not 40 or 44. Because I find in one case I can't put on the tie, in the other case it is so loose that I can't really use it in a formal occasion. That's the message that has come along. What is the current situation worldwide? There is a lot of competition. No matter what you are looking at, whether you are looking at paper, pencil, you are looking at computers, you are looking at water bottles and so on, you look at furniture, you look at electronics, you look at cars, you look at steel, there is tremendous amount of competition worldwide. So there are many suppliers. So it's a very fiercely competitive situation. And financial systems, as you know, they've become fluid, so it's difficult to get money to build your plants. Customer expectations are changing. This is happening worldwide. Employee expectations are also changing. They want more empowerment and so on and so forth. Investors obviously expect more because our horizons have become shorter. our investment horizons, they also become shorter. We'd like to get more returns in a shorter period of time. And technology is changing very rapidly. That's also something that has started to happen. If you look at various strategies, various approaches to try to do quality assurance, the least effective one is when you're trying to count everything based on inspection only. When you're trying to do your quality assurance based on inspection. It is somewhat better when you're trying to do SPC, process control. But it's best when you're trying to do trying to take proactive steps. You're doing continuous improvement, you are doing basically taking all those preventive actions and so on. We will try to see how we can leave this behind, and how we can move toward this, which is like taking the preventive actions. In fact, it turns out Six Sigma focuses on this last stage. And that is one of the secrets of succeeding with Six Sigma. So again, that picture is there. As you can really see, we moved from quality control, which is what with inspection. We went to quality assurance, which was sort of with SPC and DOE. We moved to quality engineering, which was with Taguchi. And now we moved up to Six Sigma, which is like the ultimate, the frontier of quality movement today. How do you tell us that a company is doing TQM? Is there some magic way? Is there something that you can basically take a look at the company and say, yeah, these guys seem to be practicing TQM? It's like you walk through IIT Kharagpur. Is there something that will tell you right away the director believes in TQM? The people, they believe in TQM? Is there some certain things you can notice? Obviously, something you have to remember is most organizations exist because there is a stakeholder. There are people who are interested in the delivery of the service or the product that comes out of the organization. Of course, there are many other stakeholders as well, but I'm just talking about customers. Customers have to be there. Now, how do I tell that an organization has TQM? The very first thing is top management talking customer satisfaction? Is top management talking customer delight? Is top management directly involved with the delivery of quality? Top management's direct involvement. That's like one surefire way to say that this company probably does have TQM. The second is strong customer orientation. Again, does top management talk about customers? Do they actually talk about customer requirements, customer complaints and that sort of thing? Do they interface with the customers? This is very, very important. Unless you do this, you really not know what customers really want and what are they complaining about. That you will not know unless you have strong customer orientation. Then problem solving. Should problems be solved only through experience? All you really need is some ustad, some expert, and he's kind of the master of the process and so on. Until he's there, everything works fine. At the moment he takes leave or goes on holidays or something, things kind of collapse. Should it be experience based like that, or should I be using scientific approach? So many things we do today because of science, because we are people, and you will see this later as we go into the subject here. With experiments, you can also build up experience. You can build up experience very rapidly if you do the right set of experiments. You can build up your experience very rapidly. You don't have to wait for 20 years. And again, everyone participates. That's also a sign for TQM. Everyone means everyone, right from the top, which is the top director, the director of the institute, all the way to the person who is delivering. Perhaps he's the person in a school, he's the one who cleans the boards, or he arranges the chairs, for example. He's the kind of person. Is he also involved in the delivery of quality? That's also very important. Just imagine coming to a class and finding that the blackboard has not been cleaned, or the whiteboard has got streaks of all these things that basically stain the board. Is that going to be good for those who are going to be looking at the board and trying to understand what is going on in the class? Not so good, right? The thing is, even that gentleman who is basically in charge of cleaning the place and organizing, doing the housekeeping and so on, he also should be concerned about quality. Is he oriented that way? And whose job is that? It's the job of the top management. They should do it by setting examples. And of course, the last thing that comes along in TQM is, don't be happy with what you have. Think of continuous improvement. And the Japanese have a phrase for this, they call it Kaizen. Kaizen is something that looks at small improvements. Maybe small improvement, but done a little improvement every day. Or every week, you've got some improvement done every day. If these things are there, if these 5 points are there, then you really say, is top management directly involved? Do I have strong customer orientation? Are problems solved by systematic methods, which could include statistical methods? Does everybody participate when there is a quality problem? And do we really have continuous improvement as the theme? If these things are there, the company is practicing TQM. TQM really encourages problem solving at all levels. Whoever has a problem, let him go ahead and find a solution. You encourage people, you empower people to be able to do it. And they could use simple tools or they could use some very sophisticated statistical tools. There is no problem at all. Delegation is there, the power is there, and so on and so forth, and people take actions based on that. But TQM by itself is not just a collection of tools. It's a culture. It's a way of acting, way of behaving, way of interacting, way of viewing the world, way of viewing the customers, way of viewing yourself. That's TQM. It's an attitude of mind. And as I've shown here in this slide, it's based on pride in the job, teamwork, management commitment, extending all the way to all the employees. And in fact, every department recognizes that there is a role it has to play in achieving that customer delight. TQM therefore is a culture, it's not a program. It's not something that you go through step A, step B, step 3 and so on and so forth. If you go through those steps, you'll have TQM. It's not like that. It's a state of mind. It's a culture. TQM versus quality chains. Now there is something where TQM is extending itself. Quality chains, let me just actually show you the chain and you'll know right away what I'm talking about. You look at any organization, there is not a single department that does everything. There are many departments, they have stages of production. And the transformation of the final product, starting from the input all the way to the final product, it takes place through stages. And these stages themselves, they are customers and suppliers of each other. So if you look at this quality chain, you'll notice I've written there the external customers who is right at the top. Then I've got a supplier who is supplying this external customer. Then I've got a customer. Because the same supplier is a customer of the previous stage. And this stage here is the customer of the previous stage and so on. And all the way I've got an external supplier. At the bottom I've got an external supplier. So this guy is going to ship his products to this first person. He does something to it. Then it is moved to the next stage and the next stage and the next stage and so on and so forth. That's how I form the total quality chain. This quality chain is very, very important. Why it is important? Because if any of these steps stops functioning, the chain is going to break. You're not going to be able to deliver the final product the way you'd want it to be delivered. You would not be able to do that. And that is actually what highlights the idea of this quality chain. Quality chain is very, very important. If any link is weak or if any link breaks down, you'll have big problems in supplying and making sure everything stayed supplied. There are these internal quality chains. Of course, there are external quality chains also. There are certain stages when you got to make sure that the chain is intact, the chain is functioning, and that can be done through inspection. You do the process inspection at the right places and it can be done. But something you have to remember. Remember, inspection is done only at the last stage or maybe the first stage. Inspection does not impact the process itself. The process carries along unless you do SPC. Unless you do SPC, inspection which is being done at the last stage or the first stage, inspection does not really impact anything inside. Unless I utilize the inspection data and I bring back by that feedback control which I showed you in a system here, I had my diagram, I have the output coming out, then I had this data collected and I utilize that data in a feedback mode to try to control these variables C, B and A. This feedback loop is, till it is completed, really there is no really sense, no kind of control, no change in the process. And that will take place only when I am using the inspected data in a feedback manner, in a feedback fashion to try to come back and control these processes, these process variables B and C. It turned out in this particular case, A was not very important, A was not very influential in impacting the process. So I could just, all I needed to do was, I would collect the data, do a statistical transformation to get my signals. Once the signals come along, then I'll control the appropriate variable, either it will be B or C. These are process factors. Those are the ones I'll be controlling. Something I have to remember is, quality control by itself is not good enough. And that you see in the blue box there, that's quality control by itself is not good enough. Quality engineering is charged with coming up with good designs in an organization. And then there is this huge area called quality assurance. That involves many different departments. they are the ones, the action of assurance is preventive. And you'll see that as you go into the process itself, you'll find quality control is the consequence of the process. Quality control, quality assurance in some sense controls the output, controls the process when it's going on. And before quality assurance can begin, which is at the process level, I have to do what we call quality engineering. This is when we come up with the design of the product or the design of the process. And all of them, they have a role, and this then flows from QC to QA to QE. QA is the highest level. QE, quality engineering, is the highest level at which you are dealing with quality management. So again, the same climb, same climb again. Around here, I'm doing QC, quality control. Quality control is still pretty much up to this. At this point and here on, I'm trying to do a bit of quality assurance. At Taguchi, I'm doing quality engineering. And the total thing taken together, if you go all the way, I'm taking a lot of preventive actions. And this guy is trying to deliver a level of quality which is at parts per million. That is your Six Sigma process. If you do a good job in quality assurance and you want it to be known by the world outside, your customers, your competition and so on and so forth, then you get yourself audited. One way, of course, for doing that is to apply for an award, like for example the Baldrige Award. The Baldrige Award is a US award and it's based on the TQM philosophy. So if you are practicing TQM to the last piece of the concept, you could apply for the Baldrige Award. The Deming Award is a Japanese award, and the Deming Award looks at a different dimension of quality assurance. The Deming Award looks at statistical methods. Are you using statistical methods in controlling your quality, in assuring your quality, and so on and so forth? In your preventive actions, do you really have actions that are based on statistical methods? If you're doing that, you probably should apply for the Deming Prize, and that is done like that. The Baldrige Award, it came from the US, and you can see the slides and they'll give you the details where it came from. That could be done quite easily. Then of course, I've got certain criteria, and these are aspects of TQM that are checked by the auditors. They come back and see, are you doing these things? If you're doing these things, they might consider you for the award of the Baldrige Award. And it's a very fancy award, and if you win this award, you can publicize, and a lot of things are tested. The auditors are going to check and all these things, and they're going to see, are you really meeting with these things? If you are, then of course you get the award. And there are benefits. There is clearly the financial benefit, which is like you'll get more business, more customers will be coming toward you and so on. That's like something that you do. And many times, if you're a Baldrige Award winner, their practice has been, they have shared their knowledge, they have shared their good practices with other people. And there are some other advantages also in winning the Baldrige Award. The Deming Award is somewhat different. This was pushed by the Japanese. This is pushed by the Japanese Scientists and Engineers Union. They actually pushed this award. They said what is really critical here is application of statistical methods. And there are some American companies also. They have won the Deming Prize, and there are some Indian companies also that have won the Deming Prize. They are masters in use of statistical methods in process control, in design of processes, and a variety of different places where you need to optimize the process. That could be done there. So the Deming Prize, basically, it's a Japanese award, and it's focused on statistical quality control. Similarly, there are the European Quality Awards, those are there, and there are other awards, including the Rajiv Gandhi Quality Award, that's also there. That's patterned after TQM or patterned after the Baldrige Award. That's the Indian Award for Excellence in Quality. So there are now other methods that are besides just pure old TQM. You've got ISO 9000, you've got just in time, then you've got lean manufacturing, you've got poka-yoke, and of course you've got this Six Sigma Black Belt program. These are besides TQM. TQM in some sense is now an old approach. It's very powerful and so on and so forth, but it's not good enough by itself. So many people who are doing TQM, they also got registered for ISO 9000. And many moved up to JIT. Something that I should remark about JIT is, JIT basically means you get the parts into your factory, and let's say I receive these parts. I receive these parts, and I receive the caps, and I received the bodies, they came from different people. So I have my caps and I have my parts. I, as a user, as an assembler, I will not have to assemble these parts again. I will just take the part, I'll take it out of a box, I'll get the body, and I'll get the cap from another box, and I can just put them together. They arrived exactly when I needed to, and I'm doing JIT assembly, which basically says I can count on the supply, I count on the quality of the supply that I've received as these parts. I can count on the supply of parts that I've received as this body, and I can just assemble them. I can focus on assembly. I need not worry about the quality of those parts coming in anymore. And this can be done in a JIT mode, because what will the supplier do? The supplier will not stockpile stuff here that I pick from and then I do my assembly. They will not work that way. They will just say, our quality is perfect. If you take our bodies will be perfect to enter directly into your assembly shop. If you get caps from us, the caps can come in with perfect quality. You won't have to worry about their quality. Just bring them in and take them to your assembly shop and just put them together, and your product would be just fine. This is JIT, just in time, but it requires perfect quality on the input side, perfect quality on each of the components, be it part, be it whatever. It requires you to have perfect quality on the input side. Only then you can have JIT. So JIT by itself cannot be done unless you've got perfect quality. Again, defects at parts per million level. Because suppose you find that this cap does not really fit this body, and you have to hunt around for another piece of body which is going to fit this cap. Is that not going to slow down your process? How could you do JIT just in time? Because your customer also expects just in time delivery. You would not be able to do it unless these parts themselves, they were supplied in perfect order and perfect quality. That's something I've got to keep in mind. This Six Sigma Black Belt program, and this is going to be the focus of our lecture, we'll be getting into this deeper. It's a specialized program. It requires a lot of good training, and only then it can get into impacting the process. So impacting the process is going to be very important. I have to really be mindful of that. The goal really is to reach that ultimate high level of quality. The low level of defects, that's what I want to get to. And it will require some special techniques, some training in statistical methods, some other training in team building and leadership and so on and so forth. Those all will have to be there, and we'll find them as we move into this program. As we go through the lectures, you'll find all those things are gradually being brought into the thing. What was wrong with TQM? Could we not just fly with TQM? The big problem was that TQM did not quantify the incentives for improvement. So quantification of incentives, that was something that was missing in TQM. This was something that was missing in TQM. It had all the good stuff, but it was missing this quantification incentives. So what ended up happening was, when Six Sigma came along, that gap was filled. That gap that existed because there was no incentives quantified by TQM. When I did TQM, I took it on faith that this is going to be good for my company. It's only when Six Sigma came along, I could see there was a reason for me to do this project, this improvement project. So that's how Six Sigma ended up with an edge over TQM. Then of course you've got ISO 9000. I should say very briefly, this is a good way to put your house in order. It has got components. If you go through them, your equipment is calibrated. For example, you have an idea of your CPK. You have a system by which you select your vendors and so on, how you approve your vendors and so on. There's a set process for it and so on, how you control your process and so on and so forth. So basically all your quality assurance practices, they get organized. Once you have ISO 9000, your house, it's set up in a proper order. Housekeeping really improves. Something you have to remember, of course, is that by itself ISO 9000 does not guarantee quality. It only looks at activities that might be impacting quality, but it does not really work out this relationship between your actions and the final product quality. It does not do that. That is not the charter of ISO 9000. So for that you have to go into other methods, and you have to basically do that. So there is ISO 9000 2000, which is the latest model for it, and there are other methods also that we'll be looking at. The rationale for this, of course, is if you have no systems in place, then you start looking at ISO 9000. That's going to be useful to you. And there are certain specific objectives. You can again see, you can stop the system and you can actually see what the mean. And of course, this can be found in many different books. We will keep moving here and we'll try to see what other things could be done as we go into other systems. Quality management principles in ISO 9000, again they are available in many different places, and you can see that customer focus, leadership, involvement of people, these are all requirements in ISO 9000. And there is of course something new called ISO 14000, which is not so new really, because what ISO 14000 does, it looks at the obligation that you have toward the environment. So it's not true that I have to deliver products no matter at what cost, what impact on the environment. That is not allowable. ISO 14000 brings in regulations, and it actually says there are these practices that are okay as far as the environment is concerned, and these other practices, they are not okay. You've got to make sure you fix your process to make sure that you conform to the requirements of ISO 14000. That is to be there. So again, you can take a look at these. They'll give you this thing. Where do you start? Given this big, huge scenario, where do you start? You got to make a start of your journey toward excellence in quality. Where do you start? The most effective approach actually is the DMAIC project approach. DMAIC is the approach that is propagated by the Six Sigma philosophy, and I'll give you the details. And the second thing is, of course, you got to recognize your customers. So first you decide that yes, I'm going to be following the DMAIC process. That's going to give you a lot of things to do. Lot of training and so on and so forth. Those would have to be done if you're going to be doing things the DMAIC way. And DMAIC is the core of the Six Sigma process. You have to recognize customers, that's something that is to be done. You have to set performance standards, and these performance standards should be such that they meet customer requirements, they can deliver them. And there is this concept of capability, process capability. So if you have a process, you got to make sure it is capable of satisfying customers. That means it's capable of producing shirts that are size 42, that come well within specs. That's something that will have to be done. You'll have to probably establish some management systems, quality management systems, and you'll have to set the quality policy. Some of these are required by ISO 9000, and you have to empower people who can really impact quality. These are the people you'll have to empower. There's a method to try to find out what really the customer is trying to get from us. We are the suppliers. What is it that the customer really wants? So finding what the customer wants, and also a comparison of my capability to that of competition, I apply a process called QFD, Quality Function Deployment. I'm just going to give you a glimpse of this. This is a process by which you can start with customer wants and convert those into specifications for your final product. So let's say a customer wanted to get a writing pen that would write in red ink. The writing would be in red. I'll have to interface with the customer. I'll have to find out exactly what does he want. Let's start with the pen itself. Well, probably if it's going to be a wet pen and not a pencil, it must have a cap, otherwise it's going to dry up. So the customer what does the customer want? He does not want the pen to dry up, number one. He probably wants a certain fineness in writing. He probably wants a certain life of the pen. He probably wants to make sure that his hands don't become wet when he starts writing with the pen. He probably wants to use a kind of ink that does not go through the paper. These are different requirements. Giving these requirements, then I start working with my engineer. And I tell him, well, look, these are the things that the customer said he wants. How do we deliver them? This is where you bring in engineering ingenuity, basically. You bring in real product design, and you try to come up with specifications for the final product. So you'll probably say, well, the vapor pressure of the solvent should not exceed this. The cap should have a certain kind of sealing capability, and so on and so forth. All those things you'll spell out. These are going to be now technical specifications. Let me jump a few slides here. Let me go to an example, and you'll notice how this is to be done. Let's say somebody wants to set up a dry cleaning shop on the IIT Kharagpur campus. All he knows is there are enough people here, and if he sets up a dry cleaning shop, he's going to have good business. He's checked around the area and he's gone to the tech market, he's gone to the Puran Gate, he's gone to Prem Bazaar, and he's found, yes, there are a few guys who are also providing dry cleaning service. So he's got a competition there at Puran Gate, he's got another one at Prem Bazaar, and he's got another guy who also has a Mickey Mouse kind of dry cleaning shop. He's really a dhobi, he's really a washerman, but he also does dry cleaning on the side. And he takes a look at, he makes some notes there. Then he checks with people, the users, and he starts talking to the users. And what does he find? He finds certain things which are customer requirements on the left hand side. This structure, by the way, is a matrix that looks like a house, which is why this QFD procedure sometimes is also called the house of quality. They also call the house of quality. You see the roof there, you see the walls, you see a foundation. So these are the features you find in a house. Therefore, people started calling this the house of quality. Let's take a look at what it consists of. On the left hand wall, I've written down customer requirements. And this would be found by a focus group study or in some place where you can get these customers to come together and provide you an input. So what are those inputs? It turns out that customers would like to see their clothing perfectly clean, completely clean. They'd like the press of the clothing to be perfect. That also is something they'd like to see. They'd not like to see a delay at the counter when they come there to either to collect their shirts, collect their garments, or to deliver the used garments. They should have no problem there. There should be quick turnaround. The service should be friendly. This is also something that they would like to see. Having put this down on a piece of paper, I can then ask them to prioritize. Sir or ma'am, what would you like to see done? As far as priority is concerned, which would you value the most? And then she says, probably I want it to be completely clean. Number one, I want it to be pressed very well. The third thing I want is, I want quick turnaround. The fourth thing I want is friendly service. And of course, I also want this, which is like no delays at the counter. These are the priorities. These are the wants of the customers. These are the whats. Then I assemble my engineering team. I enter the house and I ask my engineers, how do you think we'll be able to provide these facilities, these services? How will I provide completely clean garments? How will I provide well-pressed garments? No delays at the counter and so on and so forth. How would I do that? My staff starts brainstorming. Some of those are technical people, some of those are people with dry cleaning experience. They say, well, sir, we should have good training. We should have very clean dry cleaning solvent. We should have, again, filters should be, the dry cleaning filters, the solvent filter should be very clean. There should be no rust in the different pipes that basically carry these solvents from one tank to the next. The press should be very firm, and also we should have good equipment. If you have these things, we feel we can deliver these goals. We feel we can deliver these goals. So these become then the specification. They come down to specifications, and I end up with certain very technical, highly technical specs. For example, how much training? 4 hours of formal training and 2 weeks of on-the-job training for the guys who are going to be doing this dry cleaning. They have to be trained this way. Only then they will reach a certain level of training. The cleaning of the solvent, how should it be checked? Well, if you could do visual checking, if you pour that in a test tube and then of course you look at the clarity and so on, you should get a pretty decent idea whether this solvent can take another round of dry cleaning or do I have to change it. That could be done. Again, the filters, how would you check their quality? We could do visual checking every day. That we could do. No rust, again, a good check is going to be, of course, doing the proper rust checking, but we could do it in a shortcut manner. We could do it by doing some visual checking. That could be done. What about the firm press? If we change them every month, they are going to stay firm. If we go beyond 1 month with the same presses, they are going to become a little loose and soft and so on, and they won't probably provide the kind of pressing that I want on my shirt. And of course, we also have to make sure that we maintain the equipment in a good order, and for that we should probably have maintenance done on an every month basis plus on an as needed basis. Then what I do with the QFD process, with the house of quality process is, I also snoop around, I do a bit of intelligence gathering, and I perhaps talk to the workers who are working in these other 2 places, other 2 or 3 places, and I ask them, what about you guys? How good are you? How good is your cleaning? And for this, what I could do is I could do some mystery shoppers. I could send some mystery shoppers. They'll carry some, some dirty shirts and so on, and they'll submit it to those different businesses. And they'll look at their performance. And they'll come back with some ratings, and that is basically industry intelligence, which I've got on the right hand side. And there they will try to judge the performance of my competition. And with that, what they will try to do is, they will try to set my own target. My target is X. X is my target. What I'll try to do is, I'll try to set a target relative to the other guys so that I can outcompete them in the marketplace. That's what I would like to be able to do. I do the same thing for specifications also. Having done this, I have a design for my shop. I know what kind of training I require. I know what kind of solvents I require. I know how frequently it has to be checked. I know how it's going to be basically looked at, how I'm going to be looking at good equipment, and so on and so forth. All these will be done stepwise, and you'll end up with a design that's bound to succeed, because you're taking a look at all different things, and you're looking at, in the end, you're also looking at performance. This is something that was actually innovated by the Japanese. Let me give you a little story here. The Japanese, as you know, they are value add people. They'll bring raw material, convert it into some product, they'll sell the product. For example, they buy iron ore from India, and they take this iron ore back to Japan. They'll load up the ships and they'll take them to Japan. In Japan, they refine these ores and they raise the concentration, raise the iron content of these, and they have a rich set of ore then. There are certain plants worldwide that can only work with these rich ores, and the Japanese then sell these rich ores to those companies. Indians don't do that. Indians are happy just selling it to Japan, and the Japanese take these concentrated ore, they sell it to those places. Then they bring in some special type of ores and they produce some special steels, and they sell those steels then to other countries. They'll bring some special type of steel, they'll convert it into some machine tools or something, they'll sell them. So every time they're bringing in something, they're adding some value, and then they're making the sales. At one point, they realized they produced a lot of steel. And what they really found was that people didn't really want raw steel, they wanted products made out of those steels. So immediately it struck them, well, what can we produce that would use a lot of steel? We produce a lot of steel. And one product that uses a lot of steel is ships. Ships use a lot of steel. So the hull of the ship, for example, it uses a lot of steel. One ship uses thousands and thousands of tons of steel. So thus, like if you produced a lot of steel, why don't you make some ship hulls? And if you just thought of ship hulls, why not make a full ship? So they in fact started producing full ships with the steel that they were producing. But what happened was, when these ships, they obviously had to be sold, they were not used for domestic consumption. These ships had to be sold. The Japanese brought in the customers, they showed them the different ships that they had in their yard, and they said in the Kobe shipyard, they showed them a variety of different ships that were there. And the customers, they looked at those ships, and they said, well, the ships are fine, but I don't like the 3 layers of decks that you have there, and I don't like the mast there, and I don't like this, I don't like that. What the Japanese found was, because they had no contact with the users, they had basically produced the wrong design. They had produced a ship for which there was no direct market. They had to make some changes on the finished ship, and that would cost them a lot of money. This is something what the Japanese ran into. So they said, how do I prevent this? They said, one way to prevent that is to do this, is to do QFD, or do this house of quality. We start by talking to people who are going to be purchasing those ships. We find out their requirements. Then we plan the details of the ships, and we try to find out what the competition is doing. We produce a ship that's going to be meeting the requirements of my customers better than how it has been done by other people. Then of course, I'll have a ship that will sell better. They started this practice and they succeeded with this. This is how they still produce their automobiles, their electronic parts, their cameras, and a whole lot of other stuff is done by doing this QFD process. And QFD is a very popular process in Japan. Many other countries, they have also looked into this. They have also started using bits and parts of this. And this is by far the most effective way to try to maximize customer satisfaction. This is where you set targets. Remember I told you about targets, like my size 42. How would a person design a shirt for me? He has to talk to me. If it's going to be for me, a custom designed shirt, like they do in Bangkok, for example, they'll do a custom designed shirt. They have to talk to me, they have to make measurements on my body. Only then my satisfaction is going to be highest. I'll continue with this. Thank you very much.